Hi, Earth Science students. Let's talk about measuring things. So let's just talk about if you were going to make this recipe. And, take a look at it. Some butter, some sugar, a little salt, a little flour, a bunch of nuts, a whole lot of oatmeal, a little baking powder. Mix up well, heat up the oven, bake for a long time. So you might be like, that's not really that specific. And these might not turn out very well, depending on what you think is a little bit or a whole lot or what a long time is. So it's important for us to be able to make reliable and accurate measurements and also for those to be understood by others. All right, so some things that you'll see, we're going to use the metric system in science in general, and the prefixes that we'll encounter the most commonly are kilo, centi, deci, and milli. And kilo, like kilometer, means 1,000 of something. So a kilometer is 1,000 meters, and a meter is maybe about the length of your leg or so. So 1,000 of those would be a kilometer, or it's about 0.6 miles. A centimeter is more like the width of your fingernail. So it takes 2.5 centimeters or 2.54 centimeters to make an inch, to give you the idea of that kind of size. So that is 1/100th of a meter. A decimeter is 1/10th of a meter. So a decimeter, about 4 inches. And then a millimeter is very small, so that's 1/1000th of a meter. It is more like the thickness of a few sheets of paper stacked on top of each other. All right, so when you convert from one metric unit to another, you can go by multiplying or dividing by 10 to get from one place to another. Or moving the decimal place. If you remember this King Henry decided no dog could multiply, or King Henry died by drinking chocolate milk. I've heard that one a lot before. You can move up and down this track to get where you want to go. For example, if you had 200 centimeters to get to meters, which would be no prefix, you'd go to the left. And that's also what you would do with the decimal place. You would move it 2 to the left, so you'd go from 200 to 2.00, and that would be 2 meters, and that would do the conversion correctly. All right, so you can think about that a little bit, but only using one system of measurement would be very helpful. So worldwide, we could compare data. All right, so things that you'll see commonly: length, we're usually going to measure that in meters or kilometers. Volume in liters, mass in grams or kilograms, and temperature in degrees Celsius. And just a reminder, mass is the amount of matter in an object, and weight is a measure of the gravitational force pulling on that object. All right, so here's a scale that goes out and shows a meter. And, just to kind of recap this, that in 1 meter there's 100 centimeters, and in 1 meter there's 1,000 millimeters. And then 1 centimeter equals 10 millimeters. And that would have to be true, right? Because 100 times 10 is 1,000 millimeters. Okay, so if you're measuring different things, let's go through and talk about some of these. So if you wanted to measure the length of a river like the Mississippi, you'd probably measure it in kilometers. Okay, if you're going to measure the mass of a paperclip, milligrams or possibly grams would be appropriate. If you're going to measure the mass of an elephant, we would use kilograms. The width of a fingernail, millimeters, maybe centimeters. TV screen, probably in centimeters. Like, but they're in inches. Well, go to a different country and check that out. Alright, so width of a juice, or excuse me, volume of juice in a paper cup. So that would probably be milliliters. It wouldn't quite be to liters. It wouldn't be big enough. The mass of a bowl of cereal, probably in grams. If you look at food labels, they all tell you amounts in grams. Okay, the amount of salt in an order of French fries, hopefully that's in milligrams. If they oversalt it, maybe in grams. The amount of soda in a large plastic bottle, so that's going to be in liters, like a 2 liter or a 3 liter. All right, temperature of a bowl of soup in degrees Celsius. All right, so let's briefly talk about density as well. So density is mass divided by volume, or written as an equation, D equals M divided by V. Well, what density is important for is knowing that if you want to predict if something's going to sink or float or rise, more dense things are going to sink and less dense things are going to rise. And that is applicable to a lot of things. Remember when we talked about convection earlier, that heated fluids are less dense, so they rise, and then cooler fluids in other locations will follow to take their place. And that applies to air masses and ocean currents and even things in liquid to figure out if they're going to sink or float. All right, so the density of water is 1 gram per milliliter. And if an object's density is greater than 1 gram per liter, that means that it's heavier per volume than the water. And so it would sink. If it's less than 1 gram per liter, it would float. So if you're designing a boat, it would be very important for you to be able to determine whether that boat would be more or less dense than water. Because if it's more dense than water, it would not be a very good boat. All right, so that concludes this set of notes. Thanks for watching.